All right, lesson 1-2. We're going to go over some more domain, and specifically, I'm going to talk about how to define domain using algebra only. So there's a couple rules with mathematics. You can call this math rules, and it's this. You cannot divide by 0, and you cannot take a negative square root. For those of you who have seen logarithms before, you must have a positive logarithm, meaning logarithms cannot be equal to or have a 0 value or a negative value within them. So there's 3 rules. I cross this one out because we won't see this for about 10 weeks of curriculum or so. So don't pay attention to that one for right now, though it's true. We just won't see it. These are the first 2 things. And since we're talking about domain, I'm specifically referring to the variable x, the x variable. Okay, so first, you cannot divide by 0. What that means is, if you have an equation like this, since I cannot divide by 0, that means x could not equal 0. If x is 0, we have a problem there. X could not equal 0 because if it did, you'd be dividing by 0. We're not allowed to do that. Also, you're not allowed to take a square root of a negative number. So for example, if we had this equation, x could not be negative because if it was, we'd have a problem. So you'd say x has to be greater than or equal to 0. And so a lot of these, as I go through this, I'm going to use a number line to help us out. And I'll ask the question, hey, what do we eliminate here? Is it that x cannot equal 0? Is that x cannot be a negative number? What are we eliminating? And I'm going to use this number line to help us out. So I have 4 examples here that I'm going to go over with you of how to find domain using algebra only. And what I love about this is I can give you problems like this here, which are beyond the scope of pre-calculus, or this one for domain, very complex problem, but using algebra we can solve this in a matter of about 30 seconds. And once you hit down the rules, probably even faster than that. So here they are, the 2 rules that we need to pay attention to. Cannot divide by 0, cannot have a negative square root. So when you come to a problem and you're asked to state the domain, we're going to assume it's all reals unless we break one of the 2 rules. So in this problem, are we breaking one of the 2 rules? Do we have a division? I shouldn't say are we breaking one of the rules. Let me ask you, do we have division or do we have a square root in the problem? Do you have either a division or a square root?
Square root.
We have a square root. So here's what that means. You'll draw your number line. And square root, the thing you're mathematically not allowed to do is you're not allowed to have negatives, which means I could equal 0 or I could be positive. Said another way, 0 can be less than or equal to x. That means I can be bigger than 0, the positives, or I could be equal to 0. So I'm going to solve this problem by you only take what's inside the square root, x minus 7, and I'm going to say that that is greater than or equal to 0. Greater than or equal to 0. So there's our value. And now I just do algebra 1 to solve. To get x isolated, I add 7. And just like that, we found our domain. X is going to be greater than or equal to 7. That's the domain right there. And we found that in 1 step. All we did was add 7. If you want to count this, we did it in 2 steps. I got a picture for you to show you. Here's what the picture would look like. That's not it. Where's my recording options? So here's the graph. And I know I cut off the graph just to pull up the table to show you this is a square root. It's going to the right. It starts at 7 as the table shows. It does not exist at 5, 6, any of those previous values, but at 7 it starts and it goes forever to the right. That means that x can be greater than or equal to 7. You could write this in interval notation. It would look like 7, comma, infinity. That's how you would write it in interval notation. So you could write your answer that way or that way. Either one's fine. So there's one example. I got 3 more for you. So this next problem. State the domain of this. Now remember, domain, we're going to assume it's all reals until we see either division or square root. In this problem, do you have a division or do you have a square root or neither?
Division.
Division. So what that means is on our number line, with dividing, what is it you're not allowed to divide by? The negatives or divide by 0 or divide by positives? What are you not allowed to divide by?
0.
0. So that's what I'm going to eliminate. That means x can be negatives, x can be positives. It just cannot be 0. And so the way you'll algebraically solve this is you'll say x cannot equal 0. So that's what I'm going to do. And I only pay attention to the denominator, the dividing part. I can ignore this. It will have an effect on what the graph looks like, but it will not affect my domain. So we just determine it's not all reals. So I'll say the 2x plus 5 cannot equal 0. And I do my algebra 1. Algebra 1 says to solve for x, I first subtract 5. When you're solving, if you don't know, you go opposite of PEMDAS. When you're solving again for a variable, you do the opposite of PEMDAS. So instead of starting with parentheses, exponent, all that, I start with the easiest, the subtraction. I subtract and I get 2x does not equal negative 5. Finally, the opposite of multiplication is division. And so we get our domain that x cannot equal negative 5 halves. Now that's written in inequality form. In interval form, it would look a little different. It's just saying every value but negative 5 halves, and so it would look like this: from negative infinity to negative 5 halves, union negative 5 halves to infinity. Now that's the longer way of writing it, but that's how you'd write it. And here's the picture of that. Right here. As you see this picture, the graph exists on the left, it exists on the right. The one place it doesn't hit, I added a red line to show you, was when x is negative 5 halves. That's the one place this graph does not exist. Now there's 2 domain problems. I'll do 2 more for you. Okay, let's try the third one. State the domain of this problem. So now we're gone beyond pre-cal difficulty and we're getting into calculus. What's the domain of this? Well, you follow your 2 rules. So first, we're going to assume it's all reals, that everything exists. Right now, everything's good. And then we check the problem. Do I have a division, an excess dividing in this problem?
Yeah.
Yeah, and if we do, what do we eliminate? What are you not allowed to divide by? Negatives, 0, or positives?
0.
0. It's out. And now, so now we're looking at this and we've eliminated the zeros because we're dividing. And second question, do we have a square root in this problem?
Yes.
Yes, and so what are you not allowed to have a square root of? Is it you're not allowed to take a square root of negatives, not allowed to take a square root of 0, or not allowed to take square root of positives? What are you not allowed to take square roots of?
Negative.
Negatives, so I take that away. This time, this means our x has to be bigger than 0. It has to be positive. So the inequality we'd use to solve this problem is right here. And you're only dealing with the part that's dividing and in the square root. That's it. So I'd say x squared minus 25 must be greater than 0. And you do your algebra 1 again. What's the opposite of subtracting 25? Adding 25. And so we have x squared is greater than 25. And now the tricky part. A lot of people think this is simple, but it's a very simple mistake people make all the time. The opposite of a square is a square root. However, if you are adding a square root to a problem that's not originally there, the number side of the inequality, or equal sign depending on what you have in the problem, needs to have a plus or minus. I'll say it again. If you're adding a square root that's not originally there, the only way to mathematically get the entire answer is you have to have put a plus minus in front of the square root on the number side of the equation. So I'll put that plus minus right there. Now I have that x is greater than the square root of 25 is 5, or x is going to be, now remember this rule from 5th grade, if you add a negative to an inequality, it switches direction. So x is greater than positive 5, or it's going to be less than, this flips, negative 5. So I have two answers here. X is greater than 5, X is less than -5. You can check to see if they can be combined together. So sometimes this is opening up to the 5. You can check to see if they can be combined together as like one set of inequalities. But this time it doesn't work because when I go from least to greatest, the inequalities are facing the wrong direction. This is saying that X is greater than 5, but less than -5. And that's not a true statement. Numbers get bigger as they go to the right, but this is saying that X is bigger than 5, but smaller than -5. That makes no sense. That's incorrect. I'm going to get rid of that. This is how you'd write the answer. You would write it with an or in there. If you wanted to use the other symbols, the interval notation, you would say X can be less than -5, which means it can go from -infinity to -5, or it could start at 5 and be bigger than 5. You could write it in that way. No worries, I have a picture to prove it to you. Here it is. Here's my picture. Notice this graph goes left forever, it goes right forever, but it just does not seem to exist in the center of the graph. It does not exist between -5 and 5. There's a break. So it exists being larger than 5. It exists being less than -5, but it does not exist in the middle of the two. Let's try the last one. Let's state this domain. So number line, y'all talk me through it.
Can't be divided by 0.
Can't be divided by 0. Good. Eliminate that.
No negative square root.
No negative square root. That's gone. So if it's positives, how do you say X compared to 0 is positive? Answer, you open to the X. That's the way the symbols are going to look. It's going to open to the X. So now, do I need to take the whole problem?
No.
No, I just look at the 16 minus x squared and say that is greater than 0. Let's do some algebra 1. What will we do first?
Subtract 16.
Okay, subtract 16. So negative x squared is greater than negative 16. Now, how do I get rid of the negatives? Basically, can I just flip the sides here? Can I add x squared and add 16? I'm actually going to do it this way. Is this the same thing? If I add x squared and add 16. So I added 16 to both sides. I added x squared to both sides. I'm here. Okay, now what?
You square root it.
Square root it. Anytime we square root, when it's not original, what do I need to do with this value right here?
Add the positive and negative.
Minus.
That's right. So when it's positive, the inequality stays the same way. 4 is greater than x. When it's negative, the inequality needs to switch. Negative 4 is less than x. I can try to see if these can be combined together. And this time I find out they can be, because we're saying x is greater than negative 4, but x is less than positive 4. We can do that. We can open to the right. And so this is my answer this time. It's all together as one inequality. Or in interval notation, you would say it goes from negative 4 to positive 4. And have no fear, I got a picture for that. There it is. So here's positive 4, here's negative 4. Notice the graph exists in the middle of those two. So that's how you find domain by hand. Don't forget to do bellringer number 3 here. I'm going to give you quick instructions. When you do, this is lesson 1-2. Remember, you have 4 things for lesson 1-2. You must, number 1, take attendance today, if you haven't already. Number 2, watch the YouTube videos. Number 3, take the lesson exam. And number 4, do the Alex assignment. Remember, these things here are optional for you for taking notes on the videos. These 2 links right here are optional. Today, or rather this assignment and this assignment, won't be due till Thursday of next week. But today's Thursday. What's due tonight?
The syllabus.
Syllabus is due tonight. What else is due tonight?
The 0-3 lesson.
Yeah, 0-3.
Lesson quiz, or lesson exam rather, and Alex 0-3. Those are the things that are due tonight. Questions over that?
Mr. Voorhees, we're supposed to